Hello everyone. Today we're going to continue with the next two skills in the fractions, decimals, and percentages unit, starting with equivalent expressions with percents, and then moving on to percent problems. So let's start with equivalent expressions with percents. It says, after learning to fly, Wendy reduced her daily commute time by 75%. Previously, her commute took m minutes. Which of the following expressions could represent Wendy's commute time in minutes after she learned how to fly? So we have to think about this. Notice that there's two correct answers here. So we've got to think about how we would first figure out how to find 75% of her commute time. Now, we dealt with some percentages back when we did interpreting expressions in the expressions, equations, and inequalities unit. So the first thing is, well, if it reduces her daily commute time, which is normally m minutes, that means we're going to be subtracting something. So we're going to start with m minus. Now, how do we find that reduction in time? Well, 75%, let's think about this first. First, we want to convert our percentage to a decimal, which 75% as a decimal is 0.75. And then in order to find 75% of something, what does of mean? Well, of means multiplication. So we're really taking our decimal of 75%, which is 0.75, and we're multiplying it by her commute time. So the reduction is going to be 0.75 m. So it says, which of the following expressions could represent Wendy's commute time in minutes after she learned how to fly? Well, she was originally m minutes, and now we're reducing it 0.75 m. We're looking to subtract that reduction from the original amount of time. So the correct answer here is going to be m minus 0.5 m, which, let's think about this. If I have a variable by itself, it's understood that there's a 1 in front of it. So if I take 1m and I subtract 0.75 m, that's going to leave me with 0.25 m, which I can see that answer choice D looks just like that. And if you think about it, what is 1/4 as a decimal? 0.25 m. So D and E say the same thing. Now let's take a look at the other choices so that we can figure out why those are wrong. Well, 0.75 m, that just represents the reduction in time. We want to know what the new commute is. Okay, we want to know what her commute time is now after she learned to fly. So that's why A doesn't work. And 3/4 m is the same thing as A, which is 0.75 m. And C is wrong because, as you can see, they added the 0.75 m, but it's a reduction, which means it should have been subtraction. Let's try another one of these. Aiko is wearing a magic ring that increases the power of her healing spell by 30%. Without the ring, her healing spell restores H health points. Which of the following expressions could represent how many health points the spell restores when Aiko is wearing the magic ring? So Aiko is normally at H, and the ring is going to increase the power of her healing spell, so that means we're adding. And then let's think about this. Well, 30% as a decimal. Well, we want to find, first of all, 30% of H. And then 30% as a decimal is 0.3 or 0.30. Of, again, is multiplication, just like we discussed in the previous example. So we're going to be adding 0.30 H. So we're looking for something that's going to look like this. Notice two correct answers again. Well, just like in the last one, if you have a variable by itself, it's understood that there's a 1 there. So we're looking for an answer of 1.30 H. Well, obviously it's not A because they're subtracting, and we want to increase it, which means we're adding. If I divide 130 by 100, if I scoop in 2 decimal places, that leaves me with 1.30 H, which is exactly what we're looking for. So B is correct. And then here, if I add 1 plus 3/10, well, 1 and 3/10 is equivalent to 1.3 or 1.30H. So in this case, C is correct. I can tell D is wrong because it's subtracting, and we know that it's increasing the power, which is addition. And here, whenever you see a number by itself like this, that's just a red flag that it's incorrect, because remember, to find 30% of something, you have to actually multiply it by that something. In this case, we're multiplying it by H health points. Let's try another one. Landon spent L hours at the beach last weekend. Mateo spent 15% fewer hours at the beach than Landon did. Which of the following expressions could represent how many hours Mateo spent at the beach last weekend? So it's 15% fewer hours. So we know Landon spent L hours, and if it's fewer hours, that means we're going to be subtracting. Well, we're trying to find 15% of L, and 15% written as a decimal would be 0.15. And then again, we see that of word, which indicates multiplication. So we're going to be taking Landon's hours and subtracting 0.15 L, which if you think about it, again, let's put a 1 in front of our L. 1 minus 0.15 is equivalent to 0.85 L. So let's take a look at our answer choices. L minus 1/15 L. Well, 15% is not written as 1/15. 15% would be 15 over 100, which if I were to take 15 over 100 and write it as a fraction, if I divide both of these by 5, that's going to give me a fraction of 3/20ths, not 1 over 15. So right away, A is incorrect. The next one, if I were to expand this and do that distribution step, L times 1 is 1L, minus 0.15 times L is 0.15L. Well, that looks exactly like what we have right here. So that means B is correct. 0.15L is incorrect. That just represents the percentage of hours fewer that he spent. We're looking for the total time he spent at the beach. The next one, as you can see, there's no variable here. Remember what we said. Whenever you see a number by itself, that should be a red flag that it's incorrect. That would just be L minus 0.15, which isn't going to get us to the answer we want. And as I just showed you, if I were to take 15% and write it as a fraction and simplify, it simplifies to 3/20ths. So 3/20ths represents 15%, and we have L minus 15% of L, so E would be the other correct answer for this one. Let's try one more of these. A caterpillar eats 1,400% of its birth mass in one day. The caterpillar's birth mass is m grams. Which of the following expressions could represent the amount in grams the caterpillar eats in one day? Well, he eats 1,400% of m. Well, 1,400% written as a decimal, or a number in this case, if I scoop in 2 places, that's going to leave me with 14m. So taking a look, answer choice C is 14m. And if you look at answer choice A, if I have 1,400 over 100 and I divide both of these by 100, well, 1,400 divided by 100 is 14, and 100 divided by 100 is 1, which gives us 14m also. So E would also be correct here. Okay, let's move on to some of these percent problems. So before we get into the percent problems, let's first review some steps in how to find percent of a number. So there's 2 different ways that we can use. The first method we're going to talk about is the proportion method, where you would set your proportion up just like we have here. Part over whole equals percent over 100. Your percentage is obviously the number with the percent sign. Your part is the number with the word is, and your whole is the number with the word of. You guys probably remember this from last year as is over of. Those are some good keywords to kind of help you. Identify which one's the part and which one's the whole. So it says, let's take a look at the example. It says, what is 45% of 278? Well, I see my percentage here, so I'm going to put that over 100. And then I see of 278. Of is indicating that 278 is my whole, so I'm going to put that on the bottom. And that means X is going to go on top. That's what we're trying to find. Now, we've already covered rates and proportional relationships, so hopefully we remember how to solve our proportions. We're going to find our cross products first. So we've got 100 times X is 100X. And then on your calculators, you can go ahead and multiply 278 times 45, and that leaves me with 12,510. And then my last step is to divide through by 100, which means we're just going to do 2 decimal scoops in, leaving us with 125.10 or 0.1. So 45% of 278 is going to be 125.1. So that's your proportion method. Let's just do a couple of these problems. It says, what is 58% of 324? So again, I'm going to do 58 over 100 equals, and I can see of 324. So that means 324 is our whole. And X is going to go on top. So that's going to leave me with 100X equals, let's multiply 58 times 324. That gives us 18,792. And then to get X by itself, we're going to divide both sides by 100. And again, all that does is we scoop in 2 decimal places, and that leaves us with 187.92. Number 2 says 18.6 is what percent of 240? Notice there's no percentage here. That means that that's what we're missing. So I have 18.6 is, that's your part, of 240, that's your whole. And we just said we're trying to find the percent, so that's where your variable goes, above the 100. So now we're going to solve it the same way. 240 times X is 240X. 18.6 times 100, well, we're just going to scoop our decimal 2 places. That gives us 1,860. And then our last step is to divide both sides by 240. So on my calculator, I'm going to do 1,860 divided by 240, and that leaves me with 7.75. And remember, we are finding a percentage, so that is what your percentage would be. Okay, the other method, we just did the proportion method, is your decimal method. In order to use the decimal method, you're just going to take your percentage, convert it to a decimal, and then multiply it by the whole. Now, this method only works if you're given the percentage and the whole number. So that's the only time you can use this. The other times you're just going to have to work with the proportion method. So notice this one says, what is 302% of 26? So I'm going to take 302%, I'm going to convert that to a decimal, and we know to go from a percent to a decimal, we're just scooping in 2 places. So the decimal would be 3.02. Of indicates multiplication, and then times your whole. So on your calculators, we're going to do 3.02 times 26, and that gives us our answer of 78.52. And that's your decimal method. Just a reminder, it only works when you have your percentage and your whole. So let's try a couple of these ones. What is 36% of 148? Well, 36% written as a decimal is 0.36 times 148 Let's go ahead and try that on our calculators. 0.36 times 148 gives me 53.28. And then the next one, if I were to convert 2.35% to a decimal, remember that little trick? To go from a decimal to a percent, we scoop 2 places to the right, and a percent to a decimal 2 places to the left. So I'm going to scoop this 2 places, which means we're going to end up with an empty scoop that we have to fill with a 0 as a placeholder. So our decimal for 2.35% is 0.0235, and then times 16 is going to give us our answer of 0.376. So those are the 2 different methods that we can use to find percent problems. Okay, let's take a look at the first one. Osvaldo has a goal of getting at least 30% of his grams of carbohydrates each day from whole grains. Today he ate 220 grams of carbohydrates and 55 grams were from whole grains. Did Osvaldo meet his goal and why? So as we can see, the first question is a drop down, yes or no. And then they want to know how many grams he ate and if it was more or less than his goal. So really what we're trying to find here is 30% of 220. Now if you want to do the proportion method, you can go ahead and do that. We know our whole and we know our percentage, so we'd be looking for our part. Or because I'm given the percentage and the whole here, we can do our decimal method. So I'm going to go ahead and multiply 0.30 times 220. So 0.3 times 220 gives us 66 grams. So he should be eating 66 grams from whole grains, but he only ate 55. So did he eat enough? No. And if you subtract 66 minus 55, that means that he ate 11 grams less than his goal. So that last question is again going to be a drop down where you'll have to select either more or less. Let's try another one. Anne increased the quantities of all the ingredients in a recipe by 60%. She used 80 grams of cheese. How much cheese did the recipe require? So this one's a little bit tricky. So she has an original recipe, which is 100%, but now she's increasing it by 60%. So essentially the recipe that she's using is going to be 160% of the original, which uses 80 grams of cheese. So we want to know what let me erase that. We're trying to find what the original recipe is. We want to find 160% of the original amount, and that 160% is going to equal the 80 grams of cheese that she ends up using. So we're trying to find out 160% of whatever that original recipe was. So we're going to just use our variable here. 160% of X is going to give us the 80 grams. So you could do this a couple different ways. We could set up a proportion, or we could do it algebraically. Well, my decimal for 160% is 1.6. We know we're doing multiplication here, so 1.6x is going to equal 80. Well, how do I get my variable by itself? I would divide through by 1.6, and on your calculators, go ahead and divide 80 by 1.6, and that gives us our answer, which is x equals 50 grams. Now, if you wanted to solve this using the proportion method, it is possible. It's just a little, you've got to think about it. Well, we know our percent goes over 100. So we can do 160 over 100. And remember, of represents your whole. So that means we don't know what the whole is, but we do know that the part, which is 60% more, is 80. So you could have set up your proportion this way, which would then give you 160x equals 100 times 80 gives us 8,000. And then our last step to get x by itself will be to divide through by 160. And if you divide 8,000 by 160, you also get 50 grams. All right, let's try another one. There are 20% more goblins than wizards in Magic Club. There are 220 goblins and wizards altogether in Magic Club. How many goblins are there in Magic Club? As you can see, I've already written there, this one is tricky, and to read the problem carefully. So we've got to think of this. We have wizards and we have goblins. So I'm just going to write wizards. And we know that there's 20% more goblins than wizards. So if I were to write that, that would be W plus 0.2W, because 20% written as a decimal is 0.20 or 0.2. So that's going to represent our goblins. We know there's 220 total goblins and wizards all together. So in order to determine how many goblins there are, we first have to add the two together. So we've got our wizards, which is W, plus our goblins, which is W plus 0.2W, which you can also think of as 1.2W. And that's going to equal 220 total. So remember, it's understood there's a 1 in front of your variable. If I were to add all these together, we have 1W plus, we just said this would be 1.2W, so altogether we have 2.2W equals 220, and then to get our W by itself, we're going to divide both sides by 2.2. On your calculators, 220 divided by 2.2 gives us 100. Now don't forget, that's W, which means there's 100 wizards. If there's 220 total goblins and wizards, and 100 of them are wizards, that means that 120 of them must be goblins. If you add those two together, 120 plus 100 gives us our total of 220. Like I said, some of these ones in the percent problems can be tricky. Now the last one we're going to do together is actually a percent of change problem, which has to do with percent increase and percent decrease. Now there is a formula that you need to follow, and I have it written down here in a proportion that's easy to follow. So when you're trying to find percent increase or decrease, first thing goes on top is the amount of change, that's how much it's changing, over your original amount, equals the percent over 100. Now we're trying to find the percent, so that means your variable should be over 100. Let's read the problem. It says a brand of cereal has 1.2 milligrams of iron per serving. So it had, that's the original. Then they changed the recipe so that they had 1.8 milligrams of iron per serving. What was the percent increase in iron? Well, amount of change is just the difference between the new amount and the old amount. So we're going to subtract these. 1.8 minus 1.2 gives us our amount of change, which is 0.6. So I'm going to start my proportion. Amount of change over the original. Well, it had 1.2, so that's the original. And that's going to equal our percent, which we're trying to find, over 100. And now we're just solving it like we would any proportion. 1.2 times x gives me 1.2x. 0.6 times 100, well, scoop it 2 places, gives us 60. And our last step is to get our variable by itself, which means we're dividing both sides by 1.2. 60 divided by 1.2 gives us our answer of 50%. And that's the formula you would use whether it's asking you for a percent increase or a percent decrease. All right, the correlating note-taking packet pages are pages 9 through 12. And just as a reminder, you do have those videos in Khan Academy if you would like to see additional examples. Have a great day, everyone.